Let us take a look at defining a local function inside a stored procedure. Here is a function called determine tiers, which for a given salary gets the relevant tier. We define a local variable L salary of type number and give it a value of 50,000. We define L tier to hold the tier information. Next, we define a local function getTier which returns a number. Note there is no create or replace in the beginning of the declaration of the function. We declare L return of type number. Inside, it refers to the L salary variable of the parent procedure. And if it is less than 40,000, then L return is assigned a value of 1. If L salary is less than 60,000, then L return is assigned a value of 2, and for all other cases, a value of 3. Then L return is returned back from the function. This is followed by the exception block where we have a when others handler where we print the error message and the format error backtrace and then raise the exception. With the local function being the last thing to be declared, we start the execution section of the parent procedure, and here we assign the value returned by getTiers to L tier. It will assign it a value of 2 as the L salary over here has a value of 50,000. Next, we change the value of L salary to 120,000 and again call the local function getTier and assign the value returned by it to L tier. This time, the call will return a value of 3. So all the logic does not have to be repeated and is just executed with one line to call the function. What if an exception is raised inside a local function? It will follow the same rules of exception propagation as followed by a nested block, which we saw in the exceptions module of the part 1 course. So say here instead of assigning a value of 2, we accidentally assign a value of b to L return. Now, when the procedure determine tiers is executed, it will start off with the begin keyword and then go to the statement where we are assigning L tier the value returned by getTier. At this point, it will call the function getTier. Inside the function, it will start evaluating the if clauses. If L salary less than 40,000 will be false as the salary is 50,000, the else if clause of L salary less than 60,000 would be true, where it will try and assign a character value of b to a number data type L return. This will cause the aura -06502 character to number conversion error. Since we have defined a when others exception handler, the execution will jump there. Inside, we are putting a DBMS output statement, and then from there we are again raising an exception using the raise keyword. The raise keyword makes it jump to the exception handler section of the outer block, where again we are printing the error and the error backtrace, followed by another raise to raise the exception to the calling client. What if we have a variable with the same name inside the local subprogram? It will override the visibility of the parent variable. Here, we have declared a variable L salary also inside the function getTier, which overrides the visibility of L salary variable defined in the parent procedure. So the call to the function will always return 1 as it does not see the L salary variable in the outer procedure, and L salary of 30,000 in the inner block will satisfy the first if of L salary less than 40,000, returning a value of 1. This is a condition you need to be careful about. We saw earlier that the local variable of the parent subprogram is in scope for the inner subprogram. The local subprogram variables are out of scope for the outer procedure. The inner subprogram can read as well as write to the outer program variables. Here, we have rewritten the same procedure but made the local subprogram getTier as a procedure instead of a function. Inside getTier procedure, we directly assign value to L tier of the parent variable. It will again give us the same results when executed.